All right, today we're going to tackle one of the biggest questions in AI. How do we take these incredible tools, like ChatGPT, and make them actually reliable? How do we hook them up to the real world in real time so we can trust them for the important stuff? Let's dive in.
Okay, so let's get right to the heart of the problem. Large language models, or LLMs, are amazing, no doubt. But they've got this one huge flaw: they can make stuff up and sound completely confident about it. It's called hallucination, and it's the number one reason you can't just plug these things into a critical business process. I mean, you can't trust an AI that might just invent its facts, right? So, how do we fix it? This comparison here really nails it. On the left, you've got your standard LLM. A great way to think of it is like a brilliant student who aced every exam, but then got locked in a room with no new books or internet access. All their knowledge is frozen in time. But on the right, that's the goal: an AI that's plugged into the world. It can see live data, it can look at your company's private files, and most importantly, it grounds its answers in facts you can actually check. It's transparent, it's trustworthy. The piece of tech that builds this bridge to the real world is a complete game changer. It's called Retrieval Augmented Generation, or as everyone calls it, RAG. This is the absolute key to building AI you can actually rely on. So what exactly is RAG? Well, the best analogy is that it gives the AI an open book test. Before the language model even tries to answer your question, the RAG system acts like a super fast research assistant. It zips through all of your external knowledge, your documents, your databases, your live data feeds, and it retrieves the most relevant, up-to-date facts. Then it hands that information to the LLM and says, okay, here's everything you need to know. Now answer the question based only on this. And the benefits of doing it this way are huge. For one, it's way more cost-effective than trying to constantly retrain a gigantic AI model from scratch. It's also really flexible. You can just plug in new data sources as you need them. And the real kicker? Transparency. You can actually see the exact sources the AI used to come up with its answer, which is absolutely essential if you're ever going to trust it. Okay, so if RAG is the brain, then it needs a central nervous system, right? It needs a way to get all that live, real-time data from the world into the brain. So the next logical question is, how do we actually build that pipeline? Well, the solution is a really powerful open source setup, often called the F-Link stack. It's a proven, battle-tested architecture for building these kinds of real-time data pipelines. It's a combination of three incredible technologies: Apache NiFi, Kafka, and Flink, that work together like a dream team to get any data to your AI instantly. So let's meet the players on this team. First up is Apache NiFi. Think of NiFi as your universal data collector. It's the field agent that can go anywhere and grab anything. Data from APIs, images, documents, sensor readings, you name it. Then you have Apache Kafka. Kafka is the super reliable data highway, the message hub that moves all that data from point A to point B without ever losing a single piece. And finally, there's Apache Flink. Flink is the smart factory built right on that highway. It can process, analyze, and enrich all that data as it's streaming by in real time. Let's make this concrete with a real example: the Traffic AI project. Here's how it works. Step 1. NiFi calls an API to get a current list of all the active traffic cameras in New York City. Step 2. For every single one of those cameras, NiFi goes out and fetches the live image. Step 3. Those live images are then sent to a Vision AI model, which analyzes the traffic conditions. Is it gridlocked? Is it flowing smoothly? And Step 4. That analysis is stored and indexed in a vector database, making it instantly searchable for our RAG system. Now, look, having a pipeline and a basic RAG system is a fantastic start. But if you want to get the kind of high-quality, super precise answers that a business can actually depend on, well, you've got to go one step further. You need to optimize the RAG process itself. And this brings us to the million-dollar question. Your knowledge base might have millions of pieces of information in it. So how do you make sure your RAG system retrieves the perfect little snippet of context, and not just something that's kind of close? Getting this right is what separates a cool demo from a system you can actually put into production. To really nail this, you have to tune three key areas. The first is called intelligent chunking, which is all about how you break your documents up into searchable pieces. Second is choosing the right hybrid embedding, which is about finding the best way to represent your information for the AI. And third, and this one is a real game changer, is metadata filtering. This lets you use structured data to narrow down the search before it even starts, giving you way more precise control. Let's just zoom in on chunking for a second, because this makes such a difference. The naive way, on the left, is to just chop a document into pieces of, say, 500 characters. But look, you end up slicing sentences and ideas right in half, the context that's completely lost. Intelligent chunking, on the other hand, understands the structure of the document. It splits things by paragraph or by section. This keeps the full context intact, and that leads to dramatically more relevant and complete answers from the AI. So we've built this system that can pull in real-time data and use it to answer questions with accuracy. That's awesome. But what this architecture really unlocks is something even more powerful. It gives us a peek into the future of AI, a future where the AI doesn't just answer our questions, it actually acts on them. Because getting smarter answers, as great as that is just the beginning. The real revolution kicks off when these systems can take action based on all that real-time information they're getting. And this leads us to this amazing concept of agentic workflows. See, an agentic AI doesn't just respond to a question. It can understand a complex goal, create a multi-step plan to achieve it, and then use tools like that data pipeline we just designed to actually execute the plan. It can call APIs, query databases, and talk to other systems to get things done, all on its own. And really, that's the crucial takeaway here. By connecting AI to the world with real-time data, we're not just building a better encyclopedia, we're giving it hands and feet. We're transforming it from a passive information source into an active problem solver. Which leaves us with a final and pretty fascinating question. When our AI can both understand the world in real time and act on it, what problems are we going to solve next?